So hello everyone, welcome to our new video. Today we are going to do another problem called as finding the peak of the mountain array. Here also we are going to use the binary search. So now let's have a look at the problem, what the problem says about. So here I will be given an array here, just something similar to like this: 10, 20, 30, then 90, 80, 60, 50, 40. So here if I look, how was the elements before this? The elements would have been 10, 20, 30, 40, 50, 60, 80 and 90. So here what has been done? This was a completely sorted array from 10 to 90, and from this 40 to 90, this segment it was rotated. This entire segment was rotated here and it became 90, 80, 60, 40, 60, 50 and 40. So now here what we have to do, why we are said to find the peak of this mountain array. How this array is called as a mountain array. Let's have a look here by plotting it into a graph. So suppose if I have a graph over here, if I have to plot the points here, suppose here I have 10, 20, then here I will have somewhere 90. After 90, keep on coming down. So here I have 80, 60, 50, 40. If I join these points, this will be looking somewhat like this. The values in this array are 10, 20, 90, 80, 60, 50 and 40. So isn't the graph looking like a mountain? Yes, that is why it is called as mountain array. So which is the peak right now? The peak is here at 90. Sorry, here I forgot to place 30 here. Suppose here somewhere I have 30, or let it be. Even if 30 is not there, it does not make any difference. Okay, so here we have 90 here as the peak. 90 we have the peak. What is the index for 90 here? We have the index here for 90 as 3. We have to return the index 3 where we have the peak element. So now the point is, I said that we are going to use here binary search. Now you might be thinking, how are we going to use binary search over here? Binary search can only be implemented when the array is sorted, but this one clearly looks that it is not sorted, right? So just have a look, how are we going to implement binary search over here? So here if I say this values 10, 20 and 30, is this sorted? Yes, it is sorted, definitely. Then here if I say 90 to 40, is this sorted? Yes, it is sorted in the descending order. So we have to, this is the point what we have to do actually. This is the point what we have to actually do. Now let's go back to the graph again and find out that how we are going to find out the peak here. So here we had this graph, right? Now here if I say that wherever we get a mid value, then what we would do? We will go on the right side or we will go on the left side, right? Now for here, while going on the right side or while going on the left side, what will be the conditions over here? Now suppose I have the left slope here, I have the right slope here. Suppose if my mid value comes on the left slope, then it is clear my peak will be on the right side. If my mid comes on the right slope, then there also it is fixed that my peak will be coming on the left side this time. So how and what will be the condition? Suppose here if I consider this values 10 to 20, and let's place another one here as 30, which we actually have. Now here if I check with 20 and 30, any value at index I, that is it is definitely less than the value at index I plus 1. Is it? So here we have to build the condition for going on the right or maybe going on the left side, however it is. So what will be the conditions here? So every time whenever we find the mid value, there we have to check. The first condition that we are going to have here is, if ARR of mid, if it is less than ARR of mid plus 1. It means the next element. If it is smaller than the next element, then it is clear that we are on the left slope. And if we are on the left slope, then what we have to do? We have to go on the right side. And what we do whenever we had to go on the right side while applying binary search, we were changing the start as mid plus 1. Now suppose if we are on if the mid value is on the right slope, then in that case, what will be the condition then? Then if we are on this side, then it is clear that the next element will be smaller. So for this case, the condition is going to be if ARR of mid, if that particular element is greater than ARR of mid plus 1. In this case, this is the second condition. In this case, it is clear that the peak is on the left side. So in this case, we will be going on the left side. Well, by changing it as n equal to mid minus 1. Okay. Now, let's have a look. When mid actually comes here at the value 90, then in that case, if it is true, so this one here becomes ARR of mid. It is greater than ARR of mid plus 1 as well as ARR of mid is also greater than ARR of mid minus 1, right? These are the different conditions here that we have. This is for the first case if we are on the left side. This is for the second case if we are on the right side. And these two conditions are there if we are exactly at the peak, when we have the mid index pointing out at the peak here. So here we will simply try to merge these two conditions. We'll simply try to merge these two conditions, because you can see ARR of mid greater than ARR of mid plus 1. It is available in two different situations. Once if we are on the right side, the other one when we are on the peak itself, right? Now let's just give it a try roughly. Let's just do the dry run and see how it works here. So here if you see right now, we have a start index which will be equal to 0. We have a end index which will be equal to 7. Now what is the next thing? We have to find the mid now. Our mid will be equal to 0 plus 7 by 2. It comes here as 3. So at the third index, whatever be the value, now what we have to do? We have to compare it. Now if I see 90, is it smaller than 30? No, it is not. Is this 90 greater than 80? Yes, it is. So it means it is satisfying the second condition, that 90 is greater than the next element. Now, if 90 is greater than the next element, then there are two possibilities. Either we are at the mid or we are on the right slope. But it is not clear that where are we. So in this case, what we have to do? We have to change the end as mid, not mid minus 1. Because if we change as mid minus 1, so here 30 will be the end right now. But what if 90 is the peak index? We don't know right now, right? So here start is going to change as mid plus 1, but end will change only as mid this time. So our new end changes here to 3. Done. Again, we will find out the mid here. 0 plus 3 by 2 comes here as 1. Done. We have 1 here. At the value 1, we have 20. Compare it with the next element. 20 is smaller than 30. It means our peak is on the right side. So our start changes to mid plus 1. Here as 2. Done. Again, next iteration 2 plus 3 by 2. We will be getting here the index as 2. Check at the index to 30. 30 is smaller than 90. So it is clear again that we are on the right slope. If we are on the right slope, we have to go on the right side again. So here mid changes to 2 and then start changes to mid plus 1 here is 3. Now again find out the mid. Mid is now 3 here. Mid is also 3, start is also 3, end is also 3. What is the main condition inside the while loop that we are doing continuously every time? Start is less than equal to end. Start is less than equal to end. Yes, it is satisfying. Find out the mid. My mid comes here as 3. I got the value here as 3. At the third index, I have 90. Is 90 greater than 80? Yes, it is greater than 80. In that case, our end changes here again to 3. Done. Repeatedly it will be happening, right? So here we have to keep this in mind, and instead of writing here as start less than equal to end, we simply have to write here as start less than end. In this case, it is going to get stuck. It will enter into an infinite loop if we don't write s less than end instead of writing here as start less than equal to end. So we have to keep this in mind now, and this is how we are going to find out. Now once it has stopped, so here whatever we return here, maybe we are returning start, maybe we are returning as end, maybe mid, whatever we return, all of these values are going to store the same index here. So this is it for the explanation. So now let's go and check how we have to do the implementation. So here we have the implementation of the program for pick element in a mountain array. It is also available on different platforms like LeetCode, HackerRank, HackerRank, Geeks for Geeks. On LeetCode, it is available as problem number 852. You can find it out there. So here I have the array. I have the values here 10, 20, 50, 40 and 30. We all can see here clearly that 50 is the peak element here. Size of the array I have here is 5. I am printing out directly whatever be the peak index. I have called the function over here. Now inside this peak index function, our start will remain as 0. Clear. Second thing, our end is going to remain the same as n minus 1, whatever we were doing in case of binary search before. Mid, we are going to find out in the same way, if start plus n minus start divided by 2. So now here, as I said, we have to write here as while start less than end instead of writing while start less than equal to end. Then here, after finding the mid index, we have to compare if the value at the mid index, if it is smaller than the next value, then it means we are on the left slope. If we are on the left slope, then we have to go on the right side because our peak is on the right side. So in that case, we have to change the start as start equal to mid plus 1. Else, if this is not the case, then it is definitely the opposite. Either we are on the peak or we are on the right side. In that case, we are doing only one single thing as end is equal to mid. If we are not on the left slope, then it is clear we are on the right side. We have to come on the left. So our end changes to end equal to mid. And again, every time we will be finding here as mid equal to start plus end minus start divided by 2. So here, this is very specific about being the total number of elements in the array. If you check on the problem statement in LeetCode, there it has been clearly written that there should be at least 3 elements in the array. Okay, and the peak element, it has to be in the middle. Nowhere it can be at the first or nowhere it can be at the very last. If it has to form a mountain, the value has to be in the middle. That is very specific about this problem, and the minimum size of the array should be 3 here. So this is it about the implementation of finding the peak index using binary search. This is a very good problem as a perspective of an interview round or maybe different competitive coding exams also. So here let's execute the program and see how it works. Here we have 50, the peak index at the index 2. So here it is giving us the perfect result as index 2 because 50, the peak element, it is there at the index 2. So now let's try making a change in the array and let's see if it is still giving us the perfect result. So here now I have changed the peak element at the index 3rd. Here I have moved 50 towards the right again. So now if I execute this, I should get here the result as the peak element is there at the index 3rd. So here it is giving me the perfect result that the peak element is there at the index 3rd here. So this is it about the implementation of finding the peak element in a mountain array. So now if you have any doubts, you can give us a comment in the comment section. We will definitely get back to you. And if you have liked the video, please press the like button because that gives us a motivation to record a new video every time. And if you have not subscribed to our channel yet, then please do subscribe to our channel and don't forget to press the bell icon so that you get a notification whenever we upload a new video. So thank you very much. Keep learning.